On this column of the page, we actually only have one problem with a bunch of parts, but I've decided to redraw this graph over and over again so I can help mark up the figure. Determine f of negative 2. That means when negative 2 is substituted into the function, what is the value of the function? We see that the graph contains the point negative 2, comma 1. I've highlighted it there on the graph and I'm pointing at it now. That tells us f of negative 2 is equal to 1. Y is equal to 1. F of x can always be thought of as y. Y equals 1 when the x input is negative 2. Now to determine f of 3, we see that 3 comma 3 is on the graph. And that tells us that f of 3 is equal to 3. In this next part, we want to find all values for which f of x is equal to negative 1. Well, here's y equals negative 1, and no values of x ever come down to that line. So the answer to part C is none. There are no values of x for which f of x is equal to negative 1. Find all x values for which f of x is equal to negative 4. Well, wow, we have a whole interval here where it's equal to negative 4. And so we're going to say all x in the interval from 0 to 2, not including the 2. Notice I was looking at the behavior in y, but I was answering in terms of x. These x values on this x interval, the y value will be negative 4. Determine the x-intercept or intercepts. Well, we can look at the graph right off the bat and we see only at one point, negative 1 comma 0, do we have an x-intercept. As far as a y-intercept goes, we have an open circle, which does not count, and then down lower at negative 4, we have a closed circle. So 0 comma negative 4 is the only y-intercept in that graph. To determine the domain, we want to see where it extends from left to right. Now I see an arrow at the left saying it's going up, but to the left as it goes up. I see an arrow at the right that says it's going up to the right. So it goes all the way to the left. It's defined. Here we got a problem at 0, but down below at 0, negative 4, it's defined. It continues to be defined until x equals 2, where there's an open circle. But there's a solid circle above it, so it's defined at 2. So basically, we have all real numbers is the domain of this function. As far as the range goes, it goes up forever. It seems like the lowest value is at the x-axis at 0, but it also takes on negative 4 down below. So we have negative 4, the number, joined together or united with the interval which starts at and includes the 0 on up to infinity.